Okay, today we're going to talk about theoretical yield calculations and percent yield. So we start with a balanced equation. We'll talk about making ammonia. It takes 1 mole of nitrogen to 3 moles of hydrogen to make 2 moles of ammonia. That is the balanced equation for making ammonia at H3. If we want to know how much ammonia we can make, assuming we have unlimited quantities of one reactant and a limiting amount of the other reactant, we will identify the question. We want to know how much ammonia that we can make. And we're going to start out going from moles to moles because that's the simplest type of theoretical yield calculations. After we get this down, we'll go from grams of one thing to grams of another thing, a little bit more complex. But right now we want to know how many moles of ammonia we can create. And let's say that our limiting reactant is that we have 12 moles of hydrogen gas. So we'll say equal to 12 moles of H2. Okay? So remember to always write your question. The unit that you're looking for is moles of ammonia. What you're given is 12 moles of hydrogen. Remember that we can put our given information over 1. Makes our given information a numerator. If we want to get rid of moles of ammonia, we can open up some parentheses and put that unit, the entire unit, moles of hydrogen, in the denominator. And now we can go to moles of ammonia, which is what we're looking for. So moles of hydrogen in the numerator, cancel with moles of hydrogen in the denominator. What numbers do we put here? Well, the ratio of moles to hydrogen to moles of ammonia is going to be the coefficients from our balanced equation. So we have 3 moles of hydrogen to every 2 moles of ammonia. So the math becomes 12 times 2 is 24. Divide by 3 would be 8. That would yield 8 moles of ammonia. That's what we call theoretical yield. In theory, we should be able to produce 8 moles of ammonia, given 12 moles of hydrogen, and of course unlimited quantities of nitrogen. Percent yield deals with reality. When we go into the lab to make ammonia, we're never going to get that full yield. We're never going to create quite that much. So if I went into the lab and I wanted to make some ammonia and I came out with 7 moles of ammonia. Okay? This is what I would call my actual yield. This is how much I actually created. The maximum that I could have created was 8 moles. And remember that we call this the theoretical yield. If I want to know my percent yield, it will be the actual yield divided by the theoretical yield times 100%. So we're going to say 7 divided by 8 times 100%. Trusty calculator. 7 divided by 8 times 100 gives us 87.5% yield. That's what we call percent yield. In order to calculate percent yield, you have to have a theoretical yield and you'll be given in actual yield. Remember, it's actual yield divided by theoretical yield times 100%. So going back to the theoretical yield calculations, remember I said that they could become more complex. If you're going from moles of one thing to moles of another thing, it's a one-step process using the coefficients from your balanced equation. It just gives you the ratio of your reactant to your product. What if, instead of being given moles and asked for moles, you were given a mass in grams of your reactant and you were looking for a mass in grams of product? So our question could look something like, how many grams of ammonia can be created with, and let's say we have 30 grams of H2. Okay. So we're looking for grams of ammonia. We have grams of hydrogen. At some point in our calculation, we're going to want to get to that mole-to-mole ratio like we did in the last step. We want to know moles of one thing to moles of another thing using those coefficients. We're not ready for that though because we don't have moles of hydrogen. So we can't relate moles of one thing to moles of another thing until we take the grams of hydrogen and convert those to moles. So I'm going to put my given information over 1. The first step will be getting out of grams of hydrogen and into moles of hydrogen. Okay? I'm going to take this whole unit, not just grams and not just hydrogen, but grams of hydrogen, and make that my denominator so it'll cancel out. Remember that I want to get into moles so I can use my mole-to-mole ratio. Okay? So grams of hydrogen per 1 mole of hydrogen is going to be the molar mass. And I'm going to round generously. I'm going to call it 2 grams. 1 mole of hydrogen is 2 grams. Grams of hydrogen in the numerator cancel out with grams of hydrogen in the denominator. If I stopped right now, my answer would tell me how many moles of hydrogen I have in my 30 grams. Remember that I'm looking to get out of hydrogen and into ammonia. Now I've got moles of hydrogen. And so I'm ready to make that step that we did in the last calculation, going from moles of given to moles of what I'm looking for. I'm looking for ammonia. Here we're going to use those coefficients. So my coefficient on hydrogen is a 3. My coefficient on ammonia is a 2. My moles of hydrogen in the numerator cancel out with my moles of hydrogen in the denominator. If I were to stop right here, I would have answered the question, how many moles of ammonia could I make with 30 grams of hydrogen? I want to know how many grams I can make, so there's one more step. Okay. We're going to take this whole unit, not just moles and not just ammonia, we're going to put moles of ammonia in the denominator to cancel out. And we're going for grams. And we can go directly from moles to grams using the molar mass. Every mole of ammonia is 14 for nitrogen, plus 3 times 1 for hydrogen, or 17 grams. Now my moles of ammonia in the numerator cancel out with my moles of ammonia in the denominator. I've got grams. So it's going to be 30 divided by 2 times 2, which is just going to cancel that function out, divided by 3, so that would give me 10 so far, times 17. If my mental math is right, that is going to give me 170 grams of ammonia. Okay. So let's break this down a little bit. When we're given grams of what we, if we have grams of our given, right, our first step is to get from grams of that substance into moles of that substance. And for this one, we use the molar mass. And the number that we're associating with the mole is 1, because 1 mole of hydrogen is its molar mass. On the last step, we're using the molar mass also. 1 mole of our product is equal to its molar mass in grams. This is the only step where you're going to use the coefficients. Once you use the coefficients from your balanced equation in this middle step, going from moles of one thing to moles of another thing, then you're done with those coefficients. Okay? So step 1, grams to mole using the molar's mass. Step 2, moles of your given to moles of what you're looking for using the coefficients. And step 3, moles of what you're looking for into grams of what you're looking for by using the molar mass. Of course, if you are doing a percent yield after that, you could be given a number. Let's say you went into the lab and you created 155 grams of ammonia. That would be your actual yield. You would divide it by your theoretical yield of 170 grams and multiply by 100%. So your percent yield is going to be 155 divided by 170 times 100. That would give us a 91% yield. Okay, that's our percent yield.